Hello and welcome to Intelligent OCR Tutorial. Today we're going to learn how to process semi-structured documents. Before starting our demo, let's quickly go over the main features and the activities included in the package. The Intelligent OCR package contains the infrastructure that enables document processing through an easy-to-use set of activities which provide full flexibility. The Taxonomy Manager is used to create and edit a set of document types that is sorted by groups and categories. We can use the created taxonomy by converting it into a .NET data type with the load taxonomy activity, and then passing it as input for activities such as classify document scope, data extraction scope, train classifiers and extractors, and present validation station. Digitize document retrieves the text from any PDF or image. There are multiple OCR engines that we can choose from when using this activity. The Classify Document Scope activity allows for the usage of any classification algorithm to identify the type of a document. The first tool of this type is the Keyword-Based Classifier activity, which targets the classification of titled documents. The Data Extraction Scope activity enables us to retrieve information from documents based on the taxonomy and document type by calling the data extraction algorithms we configure. The output of the activity is an extraction result containing all the extracted information. The object can be mapped to a dataset using the Export Extraction Results activity, or used as is for more complex queries. The Train Classifiers and Extractors Scope activity allows for the completion of the feedback loop for any classifiers and data extraction algorithms capable of learning the keyword-based classifier, for example. Now it's time to start building our workflow. We'll draw information out of 2 invoices and 2 letters. To be more precise, we will extract the invoice number, the date, as well as the table. The information we'll retrieve from the letter consists of the date, the sender, and the receiver. Firstly, we need to read the files. For this, we will add 2 assign activities to the designer panel. The purpose of the first one is to retrieve the current directory, which, of course, must be stored in a variable. Let's go ahead and create one. We'll call it current folder and set its value to environment.currentDirectory. Now we can also retrieve the files using the second assign activity. We'll create another variable called documents to process and change its type to array of strings. In the value field, type directory.getFiles from the current folder, concatenated with the doc's location. Let's move on to defining the information to be extracted from the files. This is when the Taxonomy Manager comes in handy. So let's open it from the ribbon menu under the Design tab. We can see that no group, category, or document type has been defined so far for this project. First, we need to define a group and a category for our invoice. Click on the plus sign to create a new group and then type a suggestive name, such as Incoming Invoices. We can enter the same name in the category field. Moving on, let's define the document type. Click on the Add New Document Type button and enter a name. Invoice is a good one. The next step is to define the specific fields we are interested in. So we'll click the New Field button. Let's take a quick look at the menu that we've just opened. We can enter a name, specify whether our field has multiple values, and select the appropriate type out of all the available ones in the drop-down menu. Since the first piece of information we want to extract from the invoice is the number, we can type invoice number in the name field and set text as the type. Click Save. Moving on, let's define the invoice date. Enter the name and choose the date type. We can notice that our selection caused a new field to appear. The expected format section is useful when we're familiar with the incoming documents and know which format we'll encounter. We can fill in this field in a VB.NET format, like this, or leave it blank. Now let's define the items table. Provide the name and then choose the table type. We can fully customize the data to be extracted from the table by setting the specific columns we are interested in. In our case, there are 3 relevant columns: description, quantity, and total amount. And click Save. Now we've finished defining the invoice document type. We can move on to the letters. We'll define a new group, a new category, as well as a new document type. Let's name both the group and the category letters to be able to recognize them later when we retrieve them in our workflow. Click the Add New Document Type button and let's name it Letters once again. Now let's add the fields to be extracted. As mentioned before, we want to retrieve the date, the sender, and the receiver. And click Save. Now that the document types we are targeting are defined, we can close the Taxonomy Manager wizard. The taxonomy file is automatically generated in the project root in the Document Processing folder. Let's continue our workflow. The Load Taxonomy activity enables us to use the taxonomies we have just created. Let's add one to the Designer panel and create a new variable to save the output. Moving on, we'll add a ForEach activity to our workflow. Change its argument to string and enter the Documents to Process variable. In order to be able to process the incoming files, first we need to digitize them. For this, we'll use the Digitize Document activity. Provide the document path, which in our case is item, and save the output in 2 variables, DOM and docText. To extract the text, we need to use an OCR engine. Now, there are multiple available options, but in this tutorial, we'll use the Microsoft OCR engine. The next step is to classify the documents. For this, drag and drop the Classify Document Scope activity, which provides a scope for document classification. It accepts at least one classifier, as well as brokers between multiple classifiers, if that's the case. All the parameters of this activity are forwarded to the child classification activities. Let's fill the input parameters and save the output in a new variable. Now that everything has been configured, we have to decide which method we're going to use to classify the documents. Now, there are 2 options: the FlexiCapture classifier or the keyword-based classifier. In this demo, we'll go with the second option to see how it works. The required input is the path to a learning file. Navigate to the project folder and create a new empty JSON file. And then complete the dedicated field of the activity. Next, we have to activate the classifier. To do that, we'll click on Configure Classifiers. In this menu, we can find the document types we defined earlier. Since we'll use the same workflow to process all the files, let's select both options. Moreover, we can optionally set a minimum confidence threshold for the accepted classification results. The output of the activity consists of all the classification results that are above the minimum confidence threshold defined for each classifier. Based on the reported document type, we'll perform data extraction. Drag an if activity and drop it on the Designer panel. We only want to extract data if a classification result is returned. So, the scope condition is classification results.any. In the Then section, we'll use a data extraction scope activity. First of all, we'll set the file path, which is stored in the item variable. The properties of this activity include multiple input parameters that we have to set, but we can choose between classification results or document type ID. The second option can be used if no classification is necessary. To find out what the document type ID is, we can open the Taxonomy Manager wizard, select the type of document, and look above the name of the document. However, in our example, we'll use the classification results property. Let's create a variable for the output. and then enter the other variables in the fields below. For the document object model, we created the DOM variable. We've already set the document path, so let's move on to the document text and the taxonomy. We can notice that the expression we entered in the first field returned an error. That's because the output of the classification activity is a collection of reported document types within the same file, and the keyword-based classifier activity is limited to classifying an entire file into a single document type. Having that in mind, we will work with the first classification result. Now, let's also set the output, and we're done configuring this activity. Now we have to specify which extractor will be used. We'll go with FlexiCapture Extractor, and as input, we will have some templates defined in Abby Flexi Layout Studio, one for the invoices and the other for the letters. The input must be a collection of files. As a result, we'll open some brackets and insert the name of the template files separated by commas. Our next step is to configure the extractors. Here, we have to specify the information we want to extract. In the case of the invoice, we want to extract everything, so select all the checkboxes. Because we're using a FlexiCapture extractor, we need to map the taxonomy fields onto the ones defined in the Flexi Layout template. Fill in the mapping between fields, and now repeat the procedure for the letters. Configure the input parameters and the output as well. The automatic extraction results property is the output of data extraction scope activity. Now let's move on to the else branch. If the condition is not met and no classification is performed, we need to specify the extraction results value. We'll use an assign activity to set the value of extraction results to nothing. Now that the automatic data extraction part is settled, it is indicated to ask for human validation. The present validation station activity will help us achieve that by enabling users to review and correct the document classification and the automatic data extraction results. Let's set the properties of this activity. In the automatic extraction results field, we'll enter the output of data extraction scope. After filling in the other parameters, we need to create a new variable to save the output. Let's call it validated results. After this step, we need to train the classifiers in order to obtain a higher confidence score. So, drag and drop a train classifiers and extractors activity to the designers panel. This activity is helpful when using any classifiers or extractors with learning capabilities, such as keyword-based classifier, as in the present case. After the end user validates that the document was correctly identified through the validation station, the confidence of the keyword-based classifier increases. Also, if the users correct the automatically identified document type, the validation station prompts them to highlight the keyword that indicates the new document type. That piece of information is used to train the classifier in order to enable it to achieve better performance on future documents. We'll go ahead and fill in the input fields. The human validated data parameter is the output of the previous activity. Next, add the keyword-based classifier inside the body of this activity and provide the path to the learning file. In the end, we want to export the extraction results to attain a readable format for further processing. The activity that we can use in this case is export extraction results. As always, we'll provide the input, which is the previously created variable, and save the output in a variable. Now, the extracted information is stored in a dataset variable that can be used as needed. In this demo, let's write the extracted results to an Excel file. Add a for each activity and insert the dataset variable followed by .tables. Change the argument type to datatable. Next, we need a write range activity for the Excel file. Let's pick a name for our file. We'll also change the name of the sheet to the name of the file concatenated with the table name. Let's now run the workflow and see what happens. The validation station is displayed because the robot was not able to classify the invoice, since our learning file is empty. However, we'll teach the robot that this is an invoice by selecting the document group, category, and type. We also need to indicate the keyword that enables the identification of the document as an invoice. Select the invoice word and click on the bookmark button to specify that this is the keyword corresponding to this document type. Since no classification was performed, the end user must either specify if all the fields are missing or extract them manually. In this example, let's extract all the fields by hand, just as we did for the document type field. To indicate the table, click on the Mark Table button, select the content, and then click the Detect Cells button. We can notice that the description column was correctly identified, but the other ones weren't. As a result, we'll go to the Quantity column and choose the right option from the drop-down menu, and then move on to the total amount. Confirm the field selection. We can now commit our changes and save the extracted data. The same behavior is encountered in the case of the letters. Once more, we have to teach the robot that this document type is a letter and mention a specific keyword. We'll select Dear. Same as before, we have to select all the fields manually, so indicate the date, the sender, and the receiver. Moving on to the next file, we can see that the robot is now able to classify it correctly and to extract all the fields too. Click Save Extracted Data. The data identified in the second invoice is correct, so we can move on. Let's now open the Excel file and see what the exported results look like. For the first invoice, we can see that 4 Excel sheets were created. In the Simple Fields sheet, we can find all the fields extracted without any formatting. In Simple Fields Formatted, the data is formatted in such a way as to enable us to work with it in databases or applications directly. In the following 2 sheets, we can find the data extracted from the table. That concludes our tutorial for today. Thank you for watching, and until next time, happy automation!